In part 2 of section 9, I would like to discuss the geometry of the linear systems in three variables. Although we won't be graphing them ourselves, I think it's incredibly helpful to understand what kind of variations we can have whenever we have now three planes rather than just two lines as part of our system. So the case that we will be spending our time with is the one solution case right here. And the one solution case occurs when you have all three planes intersecting at one specific point. Now the picture makes it look like they all form nice 90-degree angles with each other. It's called perpendicular or orthogonal. And that doesn't necessarily have to be the case. You can certainly have them be skewed a little bit so they're not 90-degree angles, and you can still make them have a one-point intersection. And then after that, we have two more cases that we could group together. That would be the infinite number of solutions case. Now, the case that we have here for part C, where it's the exact same plane, just one on top of the other, this would be analogous to the same lines case. This would be like the same lines case. This first one over here was like the intersecting lines case. But because we're dealing with planes, there would actually be more than one way to get an infinite number of solutions. You wouldn't just have to have three of the exact same plane. You can see in the picture for part B that there is a way to orient them so that way there's an entire line of intersection. And then every point that's on that line represents a solution of the system, which there would still be an infinite number of order triples there, just like there's an infinite number of order triples on the same lines case. And then the third grouping down here at the bottom, these are both examples of no solution. And the case that's on the right here, part E, this would be analogous to the parallel lines case. So you just have spacing between each one of the planes, so therefore none of them touch each other, so no solution. But since we have three objects and not just two, we have three planes, it is possible to have intersection between the different planes, provided that you don't have all three of them crossing at the exact same time. And that's what part D represents. Part D shows that there's a little area where the blue and the green will intersect, but notice the pink one's not there at all. There's also a spot where you have the blue and the pink intersecting, but no green involved. And then a spot where you have the green and the pink intersecting with no blue involvement. So we can still get some intersection, just doesn't count as a solution because it doesn't have all three of them intersecting at the same time. But again, we will be focusing our attention on the intersecting lines case, where we should be expected to get only one solution.